Greetings and welcome to the third episode of the Pan Future Society podcast. I am your host, Sean. Today is Sunday, June 5th, 2016. Some minor housekeeping to take care of right off the top today. I noticed the comments on the website are not working as they should. While I attempt to figure out why that is, just go ahead and use the email form and drop me a line with that, or pop over to the Facebook page or the Twitter account and relay some messages over there. And now time for your news of the moment. Your news of the moment this week comes from the BBC Science News website. A flat lens made with metamaterials is promising sharper optics and much easier construction than our traditional lens technology. The first lens they've built is 2 millimeters across and finer than human hair. But it does seem to give you magnification of nanoscale objects and sharper focus than high-end microscopes that we currently use. This object has been made with metamaterials, and metamaterials are kind of a new thing for me. I had to look up what that was all about. So metamaterials, basically, as I understand it, whatever they are, their properties emerge from their structure, which I take it to mean how you put them together determines what they actually do. When I was reading about different metamaterials that are being experimented with, it kind of reminded me of the kitchen science experiment with cornstarch. You make the cornstarch liquid, and if you push on it slowly, it's a liquid, and if you slap it, it becomes a solid. So these metamaterials, it seems to be what you do with them or how you put them together determines their actual behavior. So researchers are building materials that have different properties. They call it programmable materials, like a rubber that when pressed from one direction is soft and pressed from the other direction is firm. So they've used metamaterials on this lens. The shapes on the surface of the lens are smaller than the wavelength of light involved, thousands of millimeters. So this is really nanoscale stuff, really, really tiny. The lens is unlike the curved discs that we're familiar with from cameras and binoculars and all that stuff. It's made of a layer of transparent quartz coated in millions of tiny pillars. Each of these pillars just tens of nanometers across and hundreds high. Each of these pillars reacts strongly with light, and their combined effect is to slice up a beam of light and remold it as the rays pass through the array. Then I guess it use computers to replicate that sliced up image wherever you're looking at it. In their research, they're looking. It looks like their comparison to high-end lenses currently used in microscopes, they're getting a 30% sharper image than previously. So that means you can see finer details and smaller things in your whatever it is you're looking at. This technology also apparently has other implications other than just being perhaps a higher quality, but also in the way they're made. These lenses are flat, unlike the lenses we have, which are curved. They're a convex surface. So the lenses we use now are usually molded or ground, and they're even now fairly difficult to make. So these researchers are saying that the same production facilities and techniques that are used to make microchips and memory chips could be used to make these lenses. So you basically already have the factory capacity or capability to build these ready to go. that's often a roadblock to these new technologies. You make it in the lab, you make a few of them or a few dozen of them. Maybe they're very expensive. So the next step after you've shown that it works and you want to have wider applications for it is to scale up that production, which is sometimes very, very difficult to do. But with this lens here, it looks like that large-scale production is pretty much already ready to go. The interesting thing about these lenses, too, their prototype was 2 millimeters. That was only due, apparently, to the limitations of the original manufacturing equipment in the lab. But they're saying that this method of making these lenses could be scaled to any size, 12 inches or whatever, could be a very interesting development in anything that uses a lens, from microscopes to your camera on your phone, to video cameras, to telescopes. Very interesting stuff. All right, so keep your eyes out over the next few years. See if you hear about flat lenses making their way to the mass market. And that is your news of the moment. All right, and for your deep dive item this week, I wanted to talk about a book I read several years ago called Race Against the Machine, and also about generally some of its topics, particularly the idea of technological unemployment. You may or may not have heard of that term before, but we'll get into a little bit of that. This book, written by Eric Brynjolfsson and Andrew McAfee, published in 2011. I first heard about this book from an NPR interview that they were doing, and it was one of the driving factors in my interest in future studies at the time. The book is mainly about the implications of the increasing automation in our lives. We're really looking at a time now when robots and machines various types can do just about anything, or are very close to being able to do just about anything. It's not just robot arms on an automobile assembly line, things like that. Just even in the past few months, I've been tracking a lot of stories about there's a robot chef that somebody has designed. You can program it for gourmet meals, and it will make you all by itself. It will cut things up. It will cook things. And apparently it makes really good food. There is a hotel in Japan that's being staffed by robots. There have been a couple of stories around lately. The fast food industry is very interested in automated technology, and I believe there are some restaurants also in Japan that are fairly automated, but there's also a recent article from Fortune. The CEO of Chick-fil-A was talking about wanting to develop more automation for the restaurants. And even beyond the service industry, you're seeing more and more research into art and music being done by machines. There was a very recent story about a team that programmed a computer program with algorithms derived from Rembrandt's paintings. And then it painted a portrait that looks just like a Rembrandt. And they had fed it all this data about what a Rembrandt would look like. It painted this painting, and they used some 3D technology to even give it the brush strokes that Rembrandt would have given it. And I am somewhat familiar with Rembrandt's work, and it really looks like something he would have painted. That has we'll do a segment on art in general in the future, but that is just fascinating. Is it art? Um, Another thing that popped up a couple of months ago, there's a company in Rhode Island, I believe it is, that is using IBM's Watson as a lawyer. They're basically feeding it all kinds of information and getting a result for recommendations for their clients. At this point, there are still human lawyers involved in the process, but I can imagine that as the data gets better and better and the algorithms get better and better, that we'll see the machines do more and the people do less. You're starting to see research into doing the same for doctors, which does, I think, make a certain kind of sense. If you have a computer machine, more or less a database of every known diagnosis ever of a certain set of symptoms, it can give your doctor a real reinforcement into your diagnosis or maybe some insight into treatments that you might not have thought about. But I don't know how far we are from actually having the robots do the diagnosis and the treatment without a human in between. We might never be there, actually. But anyway, back to Race Against the Machine, this book. We are kind of entering a new digital revolution, much like the Industrial Revolution of the 19th century. We are developing machines that can do things that we thought they would never be able to do. And what this is doing is not just changing the nature of jobs that are available, but it's flat out reducing the number of jobs that are available. In the Great Recession of 2008, many of those jobs that were lost never came back. And that's not because they were shipped off to another country or something like that. It's not because there aren't people around who can do those jobs. It's because we don't need people to do those jobs anymore. So I'll encourage you to read the book yourself, but I will say that the authors lay out a very compelling argument to me that this technology is going to happen one way or another. We've been on a very long arc toward this idea that more and more automation is going to happen. But it's not all bad news. In many ways, over human history, innovation in technology has led to people having more free time. We don't have to all be farmers. And, we don't have 90% of the population being farmers or something like that, just so we have enough food to eat. We don't have to be working at something from sunup to sundown every single day of the week, because that's the only way to cram enough time in to get it all done. Some of the recommendations the authors give is investing more in education. And that's certainly, I think, probably a priority number one. Just in general, we're not doing well by our educational system, at least not here in America. They also advocate for more spending in research and in communication and transportation infrastructure. So there are still areas where humans are needed to do the jobs, and we need to point our efforts at getting people into those jobs. It's several different thinkers and authors of our time have lamented the idea that we are using more and more advanced technology and none of us really understand how it works. So I think you're seeing some of this in the popularity of coding. You take coding classes or get your little Raspberry Pi device, and at least we're getting younger people interested in technology so that maybe when there comes time to enter the workforce, they'll just have sort of a different life experience that someone like myself does, and the idea of working in high-tech research, robotics or something like that is going to be completely normal to them. So if there are any younger people in the audience out there, take that into consideration when you're thinking about college or what you want to do for a career. You probably don't want to go into music like I did. One of the effects of this technological unemployment also is that it does have a downward pressure on wages. Often, the more machines are used, the more the people that still have a job in the same factory or whatever have to take concessions to be paid less or not get a raise or that sort of thing. And I think we're going to see more and more of that as we go into the future. There are some countries that are looking into solutions for this kind of a problem. I think it is Switzerland that is going to vote soon on giving everyone a minimum monthly wage. Basically, it looks like if you are of age and you're a citizen, you get a certain amount of money every month from the government. I know a lot of conservative and libertarian types out there are banging their heads on their desk right now. But we'll talk later. We'll let the politicians sort out where this money is coming from. But people have to do something to survive. I almost don't even know how to phrase this problem. If the machines do all the work, the people don't have to have jobs. If the people don't have to have jobs, how do we have homes? How do we have clothes? How do we have food? Even just our basic needs. So, I don't want to call it socialism, because that'll be too offensive to some people. But in the Star Trek future of Gene Roddenberry, in most places in the galaxy, money is meaningless because the need for commercial transactions has been so greatly reduced. The more and more our automation makes life easier for us, the more we're going to have to consider that the financial structure, the financial system that we've been living in, doesn't really work all that well for everyone. It sort of doesn't work well for a lot of people as it is. So, back to one of the upsides of this technology, having more free time. Wouldn't it be great if all of us could just do what we wanted to do with our time? What would you do? Would you play music all day? Would you travel? Would you spend more time with your family? Would you just sit around and watch TV or play video games? I don't know. Maybe us Americans would do that more than anything else. But I think I'm hopeful that this future run by machines, our future robot overlords, will watch over us well. I hope that we don't turn out like the fat people in the floating chairs from WALL-E, that Disney or the Pixar movie. I am looking forward to a time when I can walk into a restaurant or a hotel and be served by a robot. I think that would be cool. As long as this transition to this automated future comes along with a social change that we can take care of people's basic needs, and we all have food and shelter and all that good stuff. But this is something that I'm going to revisit this topic frequently, I think, because I don't think anyone's really talking about this. I never hear any politicians talking about it. They all say, let's create jobs, blah, blah, blah. No one's, and it's probably in some ways political suicide to say so, but no one is saying we're not going to need jobs because machines will do them. But that's probably, in a lot of areas, that's going to happen more and more. This is a conversation I don't hear happening in general, even as much as everybody effing loves science. People aren't talking about, I don't think, nearly enough about what scientific and technological progress is actually going to do. We've sort of put it in categories of, there's things that are happening now that make my TV better, or, oh, that's cool, I've got, better prosthesis from medical research. And then everything else is this science fiction far in the future, it's never going to happen, or I'm not going to have to deal with it. But for last week's episode, talking about the clock of the long now and 10,000 years in the future, no, this automation and robots are essentially here now, and more they're going to be part of our lives. This is near future stuff, not far future stuff. So let's talk about it. Hit me up with some emails or find me on Facebook or whatever. Tell your friends, tell your family. Get to talking about what this actually means for your life. What kind of a job do you do? Can a robot do your job? And hey, be active. Be a part of the community and the political system. Write your senators. Write your representatives. Call them. And at least put the bug in their ear that this is something that we need to be talking about more. Again, I want to return to being hopeful. I don't want to be all doom and gloom about this. I think in the long run, it's going to be a very good thing as long as we understand how the technology works. We don't just passively take in the technology the way we passively take in TV shows. And having the freedom of time to do things that are more important to us as humans is definitely going to be a good thing. All right, and that is your show for the week. Thanks once again for joining me here on the Pan Future Society podcast. If you like what you hear and you want more, you can subscribe to us on Stitcher now, and we are also available on iTunes. Come to the website for the link or search iTunes or Stitcher for the Pan Future Society podcast. As always, the podcast is also posted on the website. Come visit us there at panfuture.org, panfuture.org. Also, you can email me at sean@panfuture.org. I would love to hear from you. Once again, thank you so much for joining me. It's a pleasure to bring this fascinating information to you as always, and I will speak to you again in the future.